Let us now learn about the internal features of the upper pons. To study the internal features of the upper pons, we take a section at the level shown here. This is the outline of the upper pons. Please practice drawing this diagram. We can see the shallow basilar sulcus along the ventral midline. Dorsolateral corners are occupied by the superior cerebellar peduncles here as they descend from the midbrain to reach the cerebellum. Posteriorly, we are seeing the cavity of the fourth ventricle, which has become much narrower at this level so that it can continue as cerebral aqueduct as it ascends into midbrain. Posterior surface of the pons forms the uppermost part of the floor of the fourth ventricle with the median sulcus along the midline. Cavity of the fourth ventricle is dorsally enclosed by superior medullary velum, which is a thin sheet of white matter that connects the two-sided superior cerebellar peduncles, and this superior medullary velum forms the roof of the fourth ventricle. Here again, the section of the pons shows the same two parts, that is, an anterior basilar part and a posterior tegmental part. Basilar part has similar features as what we saw in case of lower pons. Coming to the white matter of the upper pons, we see the similar band of lemnisci, that is, medial lemniscus, trigeminal lemniscus, spinal and lateral lemnisci arranged from the medial to lateral end immediately posterior to the basilar part. We also find a pair of medial longitudinal fasciculus and a pair of tectospinal tracts arranged on either side of the midline dorsally. We find the central tegmental tracts and the rubrospinal tracts in the lateral tegmentum descending from the midbrain to reach the medulla or the spinal cord. Various other ascending and descending tracts will also be found in the lateral tegmentum, but one major change which we notice here is that the anterior spinocerebellar tracts will have now joined the superior cerebellar peduncles. Now coming to the grey matter, that is where the major difference is there between the lower pons and the upper pons. In this case, we see predominantly the nuclei of trigeminal nerve. That is, we see a pair of principal sensory nuclei of the trigeminal nerve. These receive the touch and pressure sensation from the head region and belong to general somatic afferent column. Ventromedial to these nuclei, we find a pair of motor nuclei of trigeminal nerve. Now they are belonging to special visceral efferent column, and the neurons of this nuclei will supply the muscles developed from first pharyngeal arch. At the junction with midbrain, the upper pons will also show the lower end of mesencephalic nucleus of the trigeminal nerve. Now the neurons of this nucleus are triply unique in being the only first order neurons located within the CNS. These receive the proprioceptive sensations from the head region. These are the only unipolar neurons located within the central nervous system, and these form the relay center for the jaw jerk, which is the only supraspinal monosynaptic reflex. In addition to these trigeminal nuclei, we also find the nucleus ceruleus in the floor of the fourth ventricle, which gives that bluish grey discoloration to the superior fovea. While most of the second order fibers from the trigeminal sensory nuclei cross to the opposite side and ascend in the trigeminal lemniscus or the medial lemniscus, some of the fibers ascend on the ipsilateral side as the dorsal trigeminothalamic tract. They carry the touch and pressure modalities from the principal sensory nucleus, and they reach the ipsilateral ventral posteromedial nucleus in the thalamus. Thank you very much. Hope you enjoyed this video. We will now move on to the next video, which tells you the details about structures in the pons. You can visit this site for other neuroanatomy videos. Thank you.